So, a very good evening to all. So, this will be day two of the Atal sponsored FDP, and the session three, it will be taken by Professor Dr. Nitin Kumar Tripathi, sir, who is currently the professor in Asian Institute of Technology, Thailand, Bangkok. And the topic is GIS techniques for sustainable urban planning. Before inviting our speaker, I would like to take a brief introduction about the Professor Nitin Kumar Tripathi, sir. He is a professor in remote sensing and geographical information system in Asian Institute of Technology, Thailand, as with over 35 experience in teaching, research, and projects. Currently, he is Vice President of Academic Affairs in AIT. Apart from his regular responsibilities of teaching and research at AIT, he has also served as the leader of information and communication technology and coordinator and GIS field of study. Dr. Tripathi obtained his BTech in civil engineering from NIT Warangal, MTech in remote sensing and PhD in remote sensing from IIT Kanpur, respectively. Dr. Tripathi had a total of 236 publications in his credit, including 5 books, 12 chapters in books, and 155 research papers in peer-reviewed journals and 65 conferences papers, mainly in peer-reviewed international journals. He has supervised 50 doctoral and 175 master's theses where majority of the research topics are focused on the applications of GIS and remote sensing in climate change impacts on water resources. His Scopus H index is 32 and 3,798 citations, and in Google Scholar H index 42 with 6,571 citations. On the behalf of Buddha Institute of Technology and as the co-coordinator of this Atal-sponsored FTP, I take this privilege to welcome Professor Nitin Kumar Tripathi, sir, as an international speaker for this FDP. And without wasting time, I would like to hand over this platform to you, sir. Nice to have you.
Thank you very much for introducing me and also for inviting me to Atal FDP program. And I think this is I'm feeling very proud to see so many researchers from India and who are in the evening attending this lecture. And I'm very, very happy that Buddha Institute of Technology has taken the lead in this. So uh, I will just share my PowerPoint now. So, Ankurji, are you able to see my PowerPoint?
Yes, sir.
Okay. So, all the distinguished researchers who are here today, I'm very happy and look like 101 participants are there from different parts of India, from different institutes. So personally, I'm not able to meet you, but at least virtually sitting in around 3,000 kilometers away from you, we can interact. So today I'm going to talk about sustainable urban development growth in Eastern Economic Corridor, Chonburi, Thailand, because this topic looked very relevant to India, which is growing rapidly. And when the growth is rapid, then we have to keep track whether it is friendly to ecology and in the future it will be good for the humanity and the people who are living around there. So I think this is the topic which is very relevant, and I'm sure that some of you might be working also in similar topics. So I will introduce the topic, then little bit background. I will tell about literature, then objective. Quickly, I'll go through the methodology and then results and conclusion. And then I will have questions from you. So any question in the beginning? Anybody want to ask? You can type in the chat box, I can read, and then we can. Okay. So now we all know that when I was kid, I used to read in the books that 70% of the population of India lives in villages. And it is a rural economy which is governing India. Now, the change is that in many pockets of the India, more than 70% people live in the urban areas. In total, if you see world population, 60% of the people are living in the cities. Only 40% are living away from the city in the villages or in some suburbs. So now everybody wants to live in the cities, and I think we don't have to discuss because cities have lot of facilities. So everybody is migrating to cities. So once people start migrating, and you can see here, like built up urban area population in 2019, the chart is showing in Asia 57.6% of the world, in Europe 9.7%. So in Asia, this is a one of the pronounced issue. And when so many people are living in a small area of the city and large part of the country has a very less people, what will happen? There are risk factors because in our houses, suppose it is made for like say 6 people maximum, and if 60 people come, what will happen? You can realize. So there will be a lot of resource crunch, plus the complete environment will be different, and so it will be a lot of challenges will be coming. So now this is the thing, like cities are becoming over capacity. So there are risk factor, there are sustainability challenges, and we are worried about not only green zones like which is giving oxygen to us, which is absorbing carbon and greenhouse gases, but we are also worried about blue zones, that is the water bodies, subsurface as well as surface water bodies. So we are all worried about these things, and not only for our generation, but for future generations. Then urban constructed zones, what is the changes in that? What are the changes of the forest around the cities? And what is the issue of the barren land, how they are going to be used? So many concerns are there. And then in Chonburi province, which is very near to Thailand's capital, Bangkok, there is a rapid urbanization going on because from Bangkok, if you go to the eastern side of Bangkok, and then it is called Eastern Economic Corridor, and it passes in the first province is Chonburi, and there is lot of urbanization now. I think maximum urbanization is in the first province now. Now rapidly it is going down also. Challenges include decrease in the green and blue cover, increased urban heat island. So when constructed area increases, green cover and blue cover reduces, then heat is captured into the urban areas in all the like urban canyon, you can say, high-rise building, then industries, everything, and all the heat is collected there. Current urban ecological studies mainly focus on urban centers, neglecting suburban areas despite their dynamic ecological change. So not only we have to focus on the urban centers, next is target is second level cities or suburban areas, and they can be managed properly for long term impact because the main urban centers are already consumed by the constructed areas, so not much can be done. But at least in the suburban areas, small towns which are emerging, we can have a good planning, and we can monitor their dynamic ecological nature. There is a lack of predictive model to forecast urbanization impacts on urban ecology, especially in data limited regions. This work aims to develop predictive models and a sustainable framework to manage urban ecological challenges in rapidly developing coastal zones. So this is a coastal area, and a lot of means commercial. There is a harbor also, Sriracha, and then a lot of commercial and buildings and industries are coming up in this all around the coastal areas. So this research, what we have done, we have used extensively the remote sensing technologies, machine learning, predictive modeling, focusing on urban regions and creating robust prediction model for ecological changes under various urban growth scenarios. So the various research questions dealt in this study are: how rapid is the urbanization in Chonburi by taking the past several years of data and including blue cover and green cover. So I think those people who are from the remote sensing and GIS background, they know how to do this one, how to take the satellite data and then make the classification maps and then compare that using GIS and then come out with this kind of a report. So this is the first research question that we can find out how the things are changing in the urban ecology. What are the impacts of urbanization on urban heat island in this region? How Markov chain modeling can be applied to develop accurate land use prediction models for 2030, 2040, and 2050. So not only for 2024, what will happen, or 2025, but say 25 years ahead of us, what is going to happen there. So 2030, what will happen? 2040, 2050. So Markov chain model can give us a predictive model and map. What policy recommendations can be developed to guide sustainable urban growth in the Eastern Economic Corridor based on study findings? So once all the data and scenarios are available, then decision makers can sit and make some policy. How to go for development along the Eastern Economic Corridor and also maintain the greenness, maintain the, like say, water bodies for sustainability of our population. How do changes in LULC, land use, land cover, and urban heat island correlate with population growth and urban development trends in suburban areas? That is very important. In suburban areas, we have to manage it nicely so that in future it can be properly developing. This is the Chonburi province. This is Thailand Bay of Siam, and then this is Bangkok here, and then Cha Ching Shao, and then first province in the Eastern Economic Corridor is Chonburi, then Rayong, then Chanthaburi, then Trat. And so this is the area where the Eastern Economic Corridor is developed. And you can see the red areas like Chonburi Industries. So these red colors are industrial zones in Chonburi. And there are different provinces. Sorry, this Chonburi is there are different district into this one. So as I told that Sriracha, Koshichang, and here is the harbor. And then all along this, you can see the yellow color line here. This is the main highway. Along that, we have done the study, but we have taken the whole province because you will see that later on there are connecting roads into this highway. Along with that, also a lot of urbanization is happening. Now, for development for any country, they have plans. So Thailand 1.0 before 1960, it was focused mainly on agriculture. So there were a lot of work going on, improvement of agriculture. In fact, Thailand, in the last few years back, it was the country to decide the prices of rice, paddies in the world. It was producing so much of paddy. Then Thailand 2.0 came from 1960 to 87. So light industries came into Thailand. Then Thailand 3.0 came from 1987 till say 2000 something, and then heavy industries came to Thailand. Like you will see lot of uh, uh, this thing, car industry, and then lot of other mechanical parts, and everything is being manufactured. All the computer hard disk and external disk like Seagate, Western Digital, they have their companies in Thailand. Then Panasonic, Hitachi, Toshiba, and other car industry, as I told, automobile, they are being manufactured in this country. And population of India is 1,400 million, 1.4 billion people are living. In Thailand, population is only 60 million. So it is such a small country compared to India, but highly industrialized. Then Thailand 4.0 now is running, and which will come to close within few years time, 4 to 5 years. Then they are going to enter Thailand 5.0. So this is a value-based economy. When the value-based economy is there, then they are trying to make the country grow rapidly using the high technology and deep technology things, and go for the next level of prosperity and through the business. So that is why Eastern Economic Corridor, lot of incentives are given by the government to develop industry, invite foreign investment, and a lot of industry related to artificial intelligence, IoT, and related like health IT, everything is coming up in this area. And just to tell my Indian audience, we have 11 factories by Birla in Thailand, and around 4 factories by Lohias in Thailand. And we have a very big share of Tata Steel. They have company here. They have acquired many steel companies, and Tata Steel is one of the major players. Eastern Economic Corridor. So Eastern Economic Development Plan is integrated into 20-year national strategy and comprises of development of fundamental infrastructure like road, then water, canals, and then electricity distribution, all the things which are necessary for the development of the industries. Development of digital infrastructure. So high speed internet, everything is developed here. And these provinces are smart provinces. Everything digitally through mobile you can do. Uh, Development of livable smart cities and financial centers. So you have the smart cities here, and financial centers are there where all the permissions for putting up industry, taxation, relief, and everything can be acquired. Development of targeted industries that utilize advanced technologies. So all advanced technologies only, like I told, deep tech companies are there. Development of promotion of tourism. So tourism is the backbone of Thailand economy, you can say. Like after agriculture and some industrial, tourism is the one which is also getting a lot of foreign currencies. Development of human resource, education, research, and technology. So a lot of innovative education institutions are coming up. Lot of research institutes being formed here. So you will, if you come to Thailand, then you will realize, and the circles yellow color, then we have put, and there is a airport also near to Chonburi, just on south of Chonburi, Rayong, and that is also getting some international flight plus lot of local flights. So here, these are the yellow marks which are being developed for the industrial purpose and for rapid development of Thailand 4.0. Now, I think we have to understand SDG when we are developing our country. So this is the United Nations 7 Sustainable Development Goal. There are 17 goals, and from first is the no poverty, and AIT, Asian Institute of Technology, is very high into the research of no poverty, like how to fight the climate change, how to adapt it, and also at the same time generate policies for improving the income of the communities. So no poverty is one of our top area, and we are doing very well in nation region. Then this study is on SDG 11 and 15, mainly on 11 for sustainable cities and communities, and 15 because near to Eastern Economic Corridor in Chonburi somewhat. Then after that, Rayong and Chantaburi, lot of forest is there. So how the forest can be maintained without destruction. Now, objective of the work is to prepare a SDG 11 and SDG 15 assessment framework by modeling upcoming rapid urbanization due to Eastern Economic Corridor in Thailand. So we can do a lot of application, but this study focused on developing tools in GIS and getting the data from remote sensing and some other sensors for SDG 11 and SDG 15 assessment, because that is very important. If we want to say that we have a sustainable development goal, then how will you test it? Whether you are going in the right direction, whether your policies are correct and your ecology is not being damaged. So we have developed the tools here, and that we will show you. And then land use growth models were employed for assessing future impacts of Eastern Economic Corridor and population growth. So we know that once government is giving a lot of emphasis on industrialization of high-tech advanced industries, so a lot of industries and investment is coming. With the result, a lot of people are getting jobs, and people from many rural areas are migrating to these areas where industries are there, and they are living around there. And the trend is continuing. So, and population growth in this area like Chonburi is much higher than some of the other provinces in Thailand. So it has attracted a lot of people also who are workforce. The sub-objective of the studies are to develop a framework for assessment of various factors and parameters related to urbanization. This objective is in two parts: urban ecological zonation mapping of blue-green constructed urban and urban heat island using high-resolution Landsat satellite data and using machine learning algorithm. Then modeling the current and the future scenarios for predicting the ecological zonation for 2030, 2040, and 2050. So this is the main objective. And then second objective, which I will not be able to discuss because of lack of time, that is about SDG 15. That is about forestry, how to have a sustainable forest. Then prepare a sustainable development framework for urban ecology by understanding the risk factor and proposing policy guideline for SDG 11 and SDG 15 of the study area. Then quickly I will go through the methodology. So methodology is in three parts: objective 1, 2, and 3. So objective 1, we have taken Landsat 5 data, uh, and then uh, there is a nighttime remote sensing data from VIRS, DNB. Then Landsat 5 data we have taken for band 6 thermal data to create the heat island map. And then we have taken Landsat 8, band 10, which is also thermal band, and top of the atmosphere temperature measurement. And then band 4 and band 5 for red and near infrared for NDVI, greenness computation, and taking into the model. So here we have developed from these data land use and land cover change maps for from 1995 till 2023. And after that, predictive modeling for 2030 to 2040 and 2050 we have done. Now this is the data, as I told, Landsat 5, 1995, then year 2000 Landsat 5, 2005 Landsat 5, 2010 Landsat 5. After that, we have switched over to Landsat 8, 2015 2020. Then we have taken nighttime data also. Now here we have classified the satellite data, Landsat 5, etc. And then we have created the land use land cover map. And we have taken samples, training samples. Uh, we have taken more than 700 training samples. And we have found out, we have used 4 machine learning algorithms, which are available in Google Earth Engine. So all the analysis was done in Google Earth Engine. And there all the data is available to you. So you don't have to download and get the data from anywhere. So you can use the random, we have used random forest, CART, SVM, and then uh, NAVE GIS, NAVE based method. And then we found that random forest is giving much better accuracy than other methods with the same training sample. So we have adopted random forest for classifying and making the land use land cover maps. We have also made urban heat island estimation using thermal band available in the Landsat because that is high resolution. If you take MODIS thermal band, then you will get a very low resolution, like say 1 kilometer resolution. That is not at all uh, clear, or you can say detailed. So thermal band, if you take, then it may be just uh, around say 100-meter pixels size, and then you can get very detailed information about the temperature. So these are the equations we have used to calculate the urban heat island using radiance, thermal radiance, and then making the LST maps. And then using the LST, we have calculated the urban heat island. Similarly, we have used uh, different indices, like for greenness, we have used NDVI, then vegetation index, proportion vegetation index, and LST we have used. Then we have created land surface temperature to urban heat island. We have found out the difference between that one. Now, land use land cover map, which are generated from the classification using random forest, we can see here. So we have taken 1995, 2000, 2005, 2010, every 5-year duration, we have taken the data. And since this work was going on in 2024, so up to 2023, we have taken the data. And now you can see red color is the constructed urban area. Dark green color is the forest. Light green color is like paddy or agriculture area. Then blue color is about water bodies, and then orange color is about barren land. Now you can see here along the Eastern Economic Corridor, lot of urbanization has happened because industries are there, and then very nice connectivity by high speed road. So lot of development of urbanization is there. So from 1995, now you can realize in 2023, a lot of changes has come into this area for urbanization. How much changes? Now we can see here, like in 1995, urban was 21.17%. Now here in 2000, it has become 23%. Then 2023, it has become 32.39%. So urban areas are increasing, green areas decreased, and in 2020 and 2015, little bit up green area, and after that again it is decreasing. So there is a decrease in the green area, there is a decrease in the forest area, not so alarming, but it is decreasing. But there is a significant increase in the constructed urban areas. Now this is the urban heat island. Now you can see, imagine in 1995, very less heat in many parts of Chonburi province. Now, if you see 2023, along the urban Eastern Economic Corridor, and there is one road which is going in the eastern direction, and we can see here here also lot of urban heat is accumulated. But if you see the forest, there is no means we have not got very hot areas into the forest areas, so that is quite cold. Now you can look at the legend for urban heat island. So you can see where the forest is, the temperatures are very close. They are from 12.8 to 18.24 uh, degrees Celsius. And then if you go for the urban areas, near urban areas, then you will see 31.2 to 43.8. So how much increase is there in the temperature in the same province? So from 12.8 lowest up to 43.85. That is the so much change in the temperature now. So and if the temperature is constantly high, what will happen? It will affect the health. Like we know that we cannot live in very low temperature and also very high temperature. So this is very important to plot urban heat island and see how the things are getting hotter in our surroundings. So this is the same thing by graph we are telling that urban constructed urban heat island from 38.8 maximum, it has gone to 43.85. And then in the forest area, minimum was 12 point something, and it has gone to now 34, sorry, 14.4. So there is an increase in the forest area temperature also. And of course, urbanization is very fast increase. Now this is the nighttime data. In the nighttime data, we can see here there is a brightness, and we get this data from the NOVA satellite, VIRS, DNB, and here the brightness is 5 to 20, 20 to 50, 50 to 100, and 100 to 350. So along the corridor, we can see the high brightness areas in the night. This data is collected in the night. So along the corridor, we can see, and then when we move from 2013 towards 2022, etc., we see many other peripheral routes. Sometimes these roads are missed out into daytime imagery, but in nighttime, brightness is so high compared to the surrounding, you can easily map them. So here you can see nighttime data is very important, just like urban heat island data. And in the nighttime also, a lot of light is there in that area. So that is why without the light from the sun, we can get the remote sensing data. And you can see here there are many dots, bright colored dots. So these are the areas where small townships have developed, or people are living, or some industries there. So we can track all these development through nighttime data very effectively. Now here we have taken 4 zones and created a buffer around that, along the cities, along the urban eastern economic corridor. And we have plotted urban change. So for each area, we have plotted urban change by circle, and then we have plotted light intensity in the night time, and then we have plotted urban heat island. So for different years, how the things are in different zones. So 4 zones were identified, and we have compared the result in the graph also. So first graph is about buffer zone 1, urban constructed urban change. So we can see from 1995, it is continuously increasing. So 95 to 2000, it was rapid. Then it became little flat, urban change, and then again it is rising. So urbanization is on the rise, you can say. Then second is the nighttime brightness. So initially it was like on the lower side values, then it increased, and then uh, nighttime light is increasing in that area. The last third graph is like temperature, urban heat island temperature. So it is like it is increasing first and then decrease and then it is continuously increasing, but not like uh, uh, earlier, like how the temperature. So minimum temperature, blue color is shown, that is also on the increase. In buffer zone 3, this is flat, not much increase. But buffer zone 1 and 2, we can see the very agile, means very effective changes of the temperature both in daytime and nighttime. Now, land use, land cover classes, we have used Markov chain analysis for predicting the land use and land cover in the future. So we have taken the data till say 2020 and before, and then we developed the model for Markov chain, and we predicted the urban chain, constructed urban area. So our predicted values for urban constructed area was 1565 square kilometer, and actual area is 1448 square kilometer. Then we have taken forest, green cover, blue cover, barren, and we got the predicted values, which are very, very close. So for forest area, accuracy is 96. For blue color, that is water body, is 98.6%. And then barren land, 96.7. So we can see here, we can find out predicted land use, land cover using the past data. So for 23, we tested it and we found very high accuracy is available. Then prediction of land use, land cover from 2030, 2040, and 2050. So what will happen? Like we have done the research till 2023 and we have checked it, verified it after predicting. Now, 2030, what will happen? 2040, what will happen? Scenarios about constructed urban, forest, green cover, blue cover, barren land. So you can see too many areas have become red color. Now, prediction of LULC per square kilometer, LULC square kilometer. Then 2030, 40, 50, what is happening? Here we see that urban areas are increasing. Like 2130, from 2130 it became 2358, then it became 2378 square kilometer. So urbanization is increasing from 2030 to 2050 also. And then green cover is reducing and forest is also on decline. So this is very important that water bodies are affected from 2030 to 2040, but now it is little bit controlled. So now we can see the prediction of the land use, land cover for the future, 2030, 40, and 50. So why we are doing it? We are doing it so that we can be ready for the 2050 scenario. What will happen that time and how the ecology will respond if we have very less forest cover and green cover is reducing. So people can think about some policies. Now we have compared for all classes year-wise, and you can see here that after 2023 to when we go to like 7 years 2030, there is a very rapid urbanization. Then 2040, it is still increasing, and 2050 also. So we can see here from these graph every year what will be the scenario, and we are using effectively the model data for 2030, 2040, and 2060. You can see here barren land, which is showing two peaks. It means another peak is when the land is prepared for construction purpose. Then it is also exposed and that it takes into the barren land. So here after say 2023, there is a some decrease into the barren land. There is a decrease in the green cover. There is a decrease in the blue cover. So where it is all going? It is going into constructed urban. So this is the one thing that all of you must try to understand the graphs. and that will give you some information how to develop the model. So my research student, he went to Eastern Economic Corridor Department review, and he talked to them whole day, and he got all the information written in English. Now, objective 2, it is the land consumption. Now we are going to develop the tools for our SDG 11. So here we needed data for temperature from NASA, rainfall from climate hazard, elevation and slope, soil data, drainage density, geology, flood, and cyclone data. Now here, for sustainability development goal 11.3.1, urban sustainability. So land consumption rate is to be calculated. After that, population growth rate is to be calculated. And then we have to calculate the land consumption rate to population growth ratio. And that ratio will give the, like say, idea whether urbanization is beyond uh, very rapid or in the limit. If urbanization is in the limit, then it is a good scenario. So we have to calculate LCR, that is land consumption rate, and we take the classified map of urban area for T plus N, and then divided by urban area T. And so that is the thing that we have done for all the years, like 2000 to
नमक डाल
95.
दीजिए.
And so other things, for every 2 years, we have done that one. So, and for 1995 to 2023, the top one is 1995 to 2023. That is the land consumption rate. After that, population growth rate we have managed, means calculated. So we can see here from 1995 to 2023, for the whole period, population growth is also positive. And then according to the United Nations SDG report, LCR PGR ratio, if LCR PGR is greater than 1, then higher land consumption rate than population growth rate. If LCR PGR is between 0 to 1, then equal growth rate of PG and LC. If LCR PGR is less than 0, then declining population rate for
Population growth.
changing land consumption. So here now we can see the land consumption rate to population growth rate ratio.
50.
Okay. Now LCR PGR ratio from 95 to 2023, it is 0.899. So we can see it is between 0 to 1. That is a equal growth rate for PG and LC. It means it is near about 1, but less than 1. So it is not so alarming. It is almost 0.9, but it is near to alarming actually. So I think it is a very, very good finding. And in international journal, this paper is already published. So here, when we see total period, then it is 0.899. But there are some years like 2005 to 2010, it is 3.32. It means urbanization was very, very rapid that time compared to the population growth rate. Similarly, from 20 to 23, urbanization is very rapid. Land consumption ratio was very high. But overall, it is 0.899. So 0.9, so it is at a border case. And I think if people can take the small areas and then control it, then I hope means it will be under sustainability limit. So here again, you can see like built up area per capita from 1995 to 2023. So it is going on decreasing, uh, but only from 20 to 23, it is showing little bit increase. So it may be due to the, like say, population in that year is becoming less. And then I want to tell you that population growth rate in Thailand is towards negative now. So that is why they are more sustainable, you can say. So if the population is decreasing, then there is less pressure on the ecology. Percentage of built up area. And now we can see here how the percentage of built up area changes are there. So it is showing rapid change in 2005 to 2010, 21.18%. Otherwise, in the beginning, 95 to 2000, it was around 10%, 9.92. So that we can estimate from the GIS. So prediction of SDG land consumption ratio rate to population in the year 2030, from if we compare 2023 to 30, what will happen? So LCR by log, it is uh, 0.02 uh, from 2030 to 23 to 30, then 30 to 40, it is 0.0041, and from 2040 to 50, it is 0.00036. So we can know that this is the land consumption ratio, and I think it is between 0 to 1. So in the later years, they will be able to manage it if we do not go very rapidly from now onwards. So I think this is the thing. But if you just see LCR by PGR ratio, then it is much higher. Like 40 to 50, it is okay, little bit controlled, but 23 to 30, it is 31.54, very high. So, and by map also, you can see here. Yeah, this is a 30, 40, and 50. So from 23 to 30, there is a very high sustainability alert. And after that, from 40 to 50, it is not much. Uh, it is manageable. But from 23 to 30, it will be serious. And then again, 30 to 40, also it is high. But from 40 to 50, it is a little bit controlled. That is the thing that it has shown. So this is a tool which can tell, and then people can make policies, because still there is a time for 2030 to come. So they can say that, okay, now onwards, no permission will be granted for big commercial areas to be developed along the corridor, and it can be developed means in the perpendicular roads areas, so that the distribution of growth is distributed, and greenness is uh, there, and then we can have better ecology. So for forest, I will skip right now. And this is the comparing spatial distribution of land use in 2000, 2010, and 2020. So here we can see how the things are. So all the coastal areas, we can see settlements are very high. But if you move from the coastal areas, then green cover is higher, and yellow color, that is cropland, is there. But along the coastal areas and along the third map, please concentrate, and then you will see that urbanization, etc., is mainly in the along the corridor and little bit near in the buffer areas. But as you move little farther, then it is ecology is still maintained. Now here we have also done hazard. For sustainability, hazard is very important to map. So map A is showing the hazard zones where the flood is coming regularly. So we have used the like data, and we have made the flood map, inundation map, using digital elevation model and the rainfall data in ArcGIS. And then also we have done a risk map. So vulnerability areas, like where are the urbanization center, where are the constructed areas, and then you can see the risk map. So hazard map is crossed with the vulnerability areas like urban centers or constructed urban, and then we can see the risk areas in red color. Very high, high, and moderate is yellow color. Similarly, drought. So when temperature heat is increasing in that area, there are chances of drought because surface water bodies will deplete and there will be pressure for the agriculture, and then drought may come, agriculture drought. So we have seen drought areas mapping, and we have done the drought area mapping using NDVI, etc. And then we can see very high zones of drought hazard. And then we have taken the thing for uh, Eastern Economic Corridor areas, and we found that where are the risks. So if the drought is in the nearby industrial zones and constructed urban, then it is showing very high impact in that area. It means vegetation will further be affected. Fruits, garden, flowers, everything will be affected. So complete ecology will be affected. So this drought hazard and flood hazard is also very important to map and then find out the risk for the uh, constructed areas. So multi-hazard, we combined these things and we found out that along the Eastern Economic Corridor, what are the multi-hazard zones? And we had this map. So all these maps can be very useful for the experts of policy to develop the policy so that we can make flood resistant areas plus drought resistant areas, and we know that risk is increasing, so we can come out with some guidelines. So I think this study is very useful to find out first urbanization trend, then what will be the consequences on the environment, and then uh, we have done like a discussion with Eastern Economic Corridor officers, and they were very happy to see that in a very technical way we are analyzing the things. And then SDG 11 tools we developed, SDG 15 tools we developed, and we found that there is a need for public awareness, and then we have to conduct education and training program for them so that they can be on the board to make the region sustainable and try to follow the guidelines. So impact of urbanization on land use and ecosystem is quite evident in this study, and we have evaluated using tools, mathematical tools, and then urban heat island effect we have seen, and you can see that temperature in the night means a whole temperature is restored into the constructed areas. But as you move towards the agriculture and forest areas, temperature difference is almost 20 degrees centigrade. So you can see how difficult situation people are living in the urban areas now in very high temperature. So they use lot of air conditioning, and again the greenhouse gases are there. They will trap all the temperature there. So we found that compared to statistical methods of, like say earlier we used to have multi uh, means a maximum likelihood classification, etc., for classification and developing land use, land cover. Now Google Earth Engine has given these machine learning tools, and we find random forest can be applied and very high, up to 90 plus accuracy can be obtained. Then we have developed based on Markov predictive models for future land use scenarios, and we have also done the nighttime imagery, and this nighttime imagery was very helpful because in the nighttime, all the emitted light from the where the industries are going on, it comes, and even on the road, whatever lights are there, they will be visible. So even the far remote areas, if some industries are there, some urban areas are there, so they will be highlighted. Otherwise, in the daytime imagery, everything is very difficult to locate because there will be trees and everything, so it cannot be mapped properly. But light can come out of the tree leaves also, and then whatever gaps are there, and then we can map those areas. And there is some research done for resilience and sustainable framework for means taking care about the disasters. And I think this can be very useful data for the policymakers. So I will stop here, and so thank you very much. And now I can take few questions.
Any questions from the participants end? Sir, I can see some of the questions in the chat box actually.
Okay, I will just visit the chat box. So there are 142 people now, and Mr. Anand is telling, how can we make a LULC map for future time span from where we can get data about flood? Mr. Anand, so for future you cannot get the data, but since you have the past data from 1995 till 2023, we got the data of remote sensing. So we made the land use land cover change uh, land use land cover maps. Then we have done the regression analysis in, and we developed the how the with what speed land use and land cover is changing, and then we have used that equation to map the pixels which will be converted into urban, which will be, and from which pixel it will be converting to urban, from which pixel it will be converting to barren land, and then again to urban. So this Markov analysis can be used to map the future scenarios. Then I have Miss Aarti Raha. She want the link of the paper. I will share it with uh, Mr. Ankur, and he will share with all the participants about the paper that has been published.
Any more question?
I see people even from through Annamalai, from deep south are also there. Then University, Chandigarh University, Dr. Agrawal, Dr. Alankrita Agrawal, your Vice Chancellor, Manna ji is my close friend. So I'm very happy to be here, and thank you very much. There is one question from Karthik. Sir, Landsat data gives daytime LST. Is it possible to get nighttime LST using the same? No, Landsat will be only for daytime, but if you want nighttime, then you have to take from Nova satellite, and it will give you two times, daytime and nighttime. But the problem is, for Eastern Economic Corridor, we need very high resolution temperature data. If you take 1 kilometer, you will get not so accurate result. So I think instead of taking the satellite data, I will suggest that we can have more detailed temperature mapping of the whole province with and then that data can be used to create the land surface temperature map and heat islands. So I think that can be used for nighttime. And it is a very good idea to map the nighttime urban heat island, because what happens in the night time, urban heat will shift uh, and towards the ocean. So oceans are a little bit hotter, and then urban area starts cooling down. So compared to daytime, there will be little cooling. But since a lot of gases and pollution is there, so that is not seen. But if you take some urban areas, they become cooler compared to daytime, and then heat goes towards the ocean. So urban heat island migrates. If you just see some papers about urban heat island, it is very interesting. So Rishikesh, he want K.R. Anand. He wants my PowerPoint, so I will share with you. I will share with Mr. Ankur, and then he will send to you.
I think, sir, there are no more questions.
Yeah,
It was a wonderful session. I was listening to the entire session. Thank you for enlightening us with your all the research work, references. Thank you so much for accepting my invitation. And on a very short notice, you accepted it. You promptly replied to my mails. Thank you so much. I know right now in Thailand it's around 8:30, so it's your dinner time. So
yeah,
I'm
it
also
is
sorry for that.
around 8:38. Yeah,
Yeah,
8:40 almost, yeah. But no problem. I'm very happy to be with my people from India and
okay.
sharing some work that we have done. And I look forward to more opportunities of this kind. Thank you
Next
very
time,
much.
if you are
All
in
of you, whenever you come to Thailand, I am in Asian Institute of Technology, and I'm going to write my email, and all of you can just, I will write my, it is very simple, Nitin KT to write. So my email is nitinkt@ait.asia, and you can be connected with me, and I'll be very, very happy to share my paper and my PPT, and then you can discuss with me for future research and which can be very relevant to India also. Thank you very much, Ankur, and
Thank you
please
so much,
convey my
sir.
regards to the director, sir, also,
Okay,
and
thank
hopefully
you.
we'll meet sometime.
Yes, sir. Thank you so much, sir. Thank you
Okay,
once again.
okay. Namaskar. Good night, everybody.
Good night, sir.
Good night, sir.
Good night. Good night.